रयत शिक्षण संस्था they arrange MSTCET, JEE, NEET guidance program for 11th and 12th science. Myself Mahamuni Nitin Ratnakar from Sadhana Vidyalaya and R.R. Shinde Junior College, Hadapsar, Pune. So students, we have starts the amine chapter of class 12. So this amine, it is a derivative of ammonia in which 1, 2 or 3 hydrogen atoms of ammonia replaced by same or different alkyl or aryl groups is called as amines. So look at this structure. This is the structure of ammonia. Nitrogen atom, they are bonded with 3 hydrogen atom. So in primary amine, 1 hydrogen atom of ammonia, they replaced by 1 alkyl or aryl group and they form RNH2 molecule. So this is the primary amine and the functional group of primary amine is NH2. In secondary amine, in secondary amine, 2 hydrogen atoms of ammonia, they replaced by 2 same or different alkyl or aryl groups is called as secondary amine and the general formula is R1R2NH and the functional group of secondary amine is NH. And in tertiary amine, both 3 hydrogen atoms of ammonia replaced by same or different alkyl or aryl groups is called as tertiary amine and the functional group of this tertiary amine is nitrogen atom and their general representation R3N or R1, R2, R3N. So this is the classification of amines. Out of these two classification, the secondary and tertiary amines, they are further classified as 2 types. Number 1, simple amine. So in simple amine, same alkyl or aryl groups attached to nitrogen atom is called as simple amines. So for example, in this example, 2 methyl group attached to nitrogen atom. So this is dimethyl amine. So this is the example of simple amines. Then second type, mixed amines. So when different alkyl or aryl groups attached to nitrogen atom, they are called mixed amines. For example, in this example, one CH3 group and one C2H5 group attached to nitrogen atom. So they are arranged in alphabetical order and they are called ethyl methyl amine. So this is the classification of secondary amines. So the next point, nomenclature of amines. So they are having 2 nomenclature system of amines. Number 1, common name system, and the general common name of amine is alkyl amine. So in this nomenclature system, the first write the name of alkyl group or aryl group attached to nitrogen atom and then write the suffix amine. But for secondary and tertiary amines, if same alkyl or similar alkyl or aryl groups attached to nitrogen atom, then they use prefix di or tri. But the different alkyl groups attached to nitrogen atom, then they arrange in alphabetical order. For example, so in this example, same alkyl groups attached to nitrogen atom, so then use the prefix di, then write the name of alkyl group methyl and then write the suffix amine. So they are called dimethyl amine. In second example, different alkyl or aryl groups attached to nitrogen atom, then they arrange in alphabetical order. So first write the name of this C2H5 group and name of this group ethyl, then write the name of methyl and write suffix amine. So they are called ethyl methyl amine. So this is the first nomenclature system of amines. Then second nomenclature system, IUPAC name. So general IUPAC name of amine is alkanamine. So it is a derivative of alkane in which E suffix of alkane replaced by amine, hence they are called alkanamine. So in alkanamine system, the primary amines are named replacing the ending of E of parent alkane by suffix amine, but for secondary and tertiary amines, they are named as N substituted derivative of amines. For example, suppose these 2 methyl group attached to nitrogen atom. According to this nomenclature system, the smaller alkyl group considered as n substituted group and one alkyl group considered as, or larger alkyl group considered as parent alkane. But in this example both groups are similar. So, out of these two groups one alkyl group considered as N group. So, N methyl and then second group considered as parent alkane. So, they are called methane and E suffix of methane replaced by amine. So, they are called N methyl methanamine. So, this is the IUPAC nomenclature of this compound. Then second example, CH3NH C2H5 or CH3NH CH2CH3. Out of these two alkyl groups, they are different alkyl groups. CH3 is smaller alkyl group and C2H5 is larger alkyl group. So, smaller alkyl group considered as N substituted group. So, they are called N methyl and this second molecule or second alkyl group containing two carbon atoms. So, the corresponding alkane ethane and E suffix of ethane replaced by amine. So, they are called ethanamine. So, the correct IUPAC name N methyl ethanamine. So, this is the nomenclature system of amines. So, we have discussed some examples of primary, secondary and tertiary amines. So, in primary amines the first example CH3NH2, its common name methylamine and its IUPAC name methanamine because of one carbon atom. In second example CH3CH2CH2NH2, so this is the straight chain of carbon. So, they are called N-propyl and then write the suffix amine. So, they are called N-propyl amine. But in IUPAC nomenclature system, the numbering of carbon chains start from that end which is nearest to functional group or NH2 group. So, the numbering start from this carbon atom 1, 2, 3. So, the compound containing 3 carbon atoms, so they are called propane, E suffix of alkane replaced by amine and the position of NH2 group is 1. So, they are called propane 1 amine. Then third example CH3CH and nitrogen or NH2 group attached to CH2 carbon NH2 group attached to CH carbon atom. So, they are called isopropyl amine and its IUPAC name, the numbering of carbon chains start from that end 1, 2, 3 or 1, 2, 3. This NH2 group having 2 carbon, the NH2 group present on carbon number 2. So, the corresponding IUPAC name propane 2 amine. In secondary amine, suppose 2 methyl group attached to nitrogen atom. So, the similar groups, so by using the prefix di-methylamine and its IUPAC name N-methyl methanamine. In second example CH3CH2NHCH3, they are called ethyl methylamine and its IUPAC name N-methyl ethanamine. So, this is the example of primary and secondary amine. Then tertiary amines CH3N CH3CH3. So, 3 alkyl groups are similar. So, by using the prefix tri and the name of alkyl group methyl, so the common name trimethylamine. But in IUPAC nomenclature system, out of these 3 alkyl groups, 2 alkyl groups considered as N substituted group and both groups are similar. So, they are called NN dimethyl and second and third carbon atom considered as parent alkane and they are having 1 carbon atom. So, the corresponding alkane methane and E suffix of methane replaced by amine is called as NN dimethyl methanamine. Second example C2H5NCH3CH3. Out of these 3 alkyl groups, one is larger group and 2 is smaller groups. Its common name ethyl dimethyl amine. So, arrangement of this alkyl group in alphabetical order and IUPAC name N-methyl means NN dimethyl ethanamine. Third example CH3NC3H7 and C2H5. So, this is the methyl group, ethyl group and N-propyl group. So, name of this compound ethyl methyl N-propyl amine, its a common name and its IUPAC name N-ethyl N-methyl propane 1 amine. So, this is the IUPAC nomenclature of tertiary amines. So, we have discussed some MCQ based on this classification and nomenclature system. The first MCQ, which of the following statement about secondary amines is true? So, the first option, they have 2 hydrogen atoms attached to the nitrogen atom. B option, nitrogen atom is bonded to 3 carbon atoms. C option, they have 1 alkyl or aryl group and 1 hydrogen atom attached to the nitrogen atom. And option D, the nitrogen atom is bonded to 2 alkyl or aryl groups and 1 hydrogen atom. So, question is, which of the following statement about secondary amine is true? So, in secondary amine, 2 alkyl or aryl groups are similar or different and 1 hydrogen atom on nitrogen atom. So, the correct option is D, nitrogen atom is bonded to 2 alkyl or aryl groups and 1 hydrogen atom. So, this is the answer of this MCQ. The second MCQ, identify the secondary amine among the following aniline. So, second MCQ, identify the secondary amine among the following compound. Option A, aniline. Option B, triethylamine. Option C, N-methyl aniline. And option D, cyclohexylamine. So, first we write the structures of these 4 compound. Number 1, aniline, C6H5NH2. So, it is a primary amine. Triethylamine, C2H5 thrice N. So, it is a tertiary amine. N-methyl aniline. So, C6H5NHCH3. So, they having secondary carbon atom. And number 4, cyclohexylamine, C6H11NH2. So, this is the primary amine. So, the correct option is option C, N-methyl aniline. So, it is an example of amine by ammonolysis of alkyl halide. So, this ammonolysis of alkyl halide, it is an example of nucleophilic substitution reaction. So, in this reaction, when alcoholic solution of ammonia, they react with alkyl halide and to form an RNH2, means primary amine plus HX molecule. In second step, this primary amine, so RNH2, which is react with another molecule of alkyl halide to form R2NH, means secondary amine. In third step, the secondary amine, which is react with another molecule of alkyl halide, they form R3N, means tertiary amine. And in fourth step, this tertiary amine, which is react with alkyl halide, they form R4N plus X minus. So, it is a tetraalkyl ammonium halide or quaternary ammonium salt. So, the final product of this ammonolysis of alkyl halide is quaternary ammonium salt, that is tetraalkyl ammonium halide. So, the reactivity of this alkyl halide with react with nitrogen, with react with ammonia. So, alkyl iodide is more reactive than alkyl bromide than alkyl chloride, because of the bond length in alkyl iodide is more than RBr and RCr, and this alkyl iodide bond is easily break down and to form the reaction is more faster. So, this is the first preparation method of amine, ammonolysis of alkyl halide. So, this MCQ based on this ammonolysis reaction. 4 type of reaction in ammonolysis of alkyl halide. Option A, electrophilic addition. Option B, electrophilic substitution. Option C, nucleophilic addition. And option D, nucleophilic substitution. So, this ammonolysis reaction is a type of nucleophilic substitution reaction. So, correct option D. So, in ammonolysis, the ammonia molecule, it acts as a nucleophile because the lone pair of electron present on nitrogen atom. This nucleophilic substitution reaction or nucleophilic reagent, they are already studied in 11th standard. The types of reagent, electrophilic reagent and nucleophilic reagent. So, the substance which having the lone pair of electron, they are called nucleophile. So, hence this ammonia molecule, it acts as a nucleophile and attacking the electrophile carbon atom, because of carbon atom having positive, partial positive charge. So, this NH2 group attract towards this carbon atom and this alkyl halide and displacing the halogen atom. So, this is the classic example of nucleophilic substitution, and especially it is a type of SN2 reaction mechanism. Then second preparation method, reduction of nitro compound. So, in aliphatic or aromatic nitro compound, nitro means NO2 group. So, NO2 group attached to aliphatic chain or aromatic ring, so they are called nitro compounds. So, this nitro compound they can be reduced to primary amine by using the metal acid mixtures like SnHCl. So, this is the first reducing agent. Second, iron and hydrochloric acid. Third, zinc and hydrochloric acid. So, these are the metal acid mixtures. Or another type of reagent is used to reduction of nitro compound is catalytic hydrogenation by using hydrogen and nickel, platinum or palladium catalyst or lithium aluminum hydride in ether. So, all these reagent they are reducing agent and they reduce nitro compound into primary amine, means NO2 group they are converted into NH2 group. For example, so in this example RNO2 means nitroalkane, which is react with 6 nascent hydrogen atom, they can be produced from this reagent Sn and HCl, and in this reaction the removal of 2 oxygen atom by 2 hydrogen atom and to form RNH2 means primary amine and plus twice H2O. So, this is the example of reduction of nitro compound. The another example, aromatic nitro compound. So, this nitro group attached to benzene ring by using the Fe and HCl or SnHCl. This reducing agent they reduce this nitrobenzene and this nitro group convert into NH2 molecule and they form aniline compound. So, aniline it is also example of primary amine. So, this method is useful for only preparation of primary amine from nitro compounds. So, this MCQ based on this reduction of nitro compound, which of the following is the most preferred reagent to reducing nitroethane to ethyl amine? Option A H2PT, option B SnHCl, option C FeHCl and option D ZnHCl. So, the correct option is FeHCl because this FeHCl or iron scrap and hydrochloric acid is generally preferred to large scale preparation, especially for the aromatic nitro compound. So, this is because the FeCl2 formed during the reaction gets hydrolyzed release hydrochloric acid, meaning the only small amount of hydrochloric acid required to initiate this reaction and making it more economically form the product of amines. So, this is the most correct answer of this MCQ is FeHCl. Then third preparation method, reduction of alkyl cyanide. So, this alkyl cyanide they are also called as alkane nitrile. So, in primary amine can be obtained by the reduction of alkyl cyanide with sodium and ethanol. This reduction method is called as Mendius reduction. So, this is the name reaction which is used to prepare the primary amine from alkyl cyanide or alkane nitrile. So, in this reaction, suppose this RC triple bond N means alkyl cyanide, they are also called as alkane nitrile, which is react with 4 nascent hydrogen atom, sodium metal in ethanol or lithium aluminum hydride. So, in this reaction, this breaking of carbon nitrogen triple bond and this nitrogen 4 out of this 4 hydrogen atom, 2 hydrogen atom attached to this carbon atom and 2 hydrogen atom attached to nitrogen atom and to form RCH2 NH2. So, the formation of primary amine. For example, this CH3CN means methyl cyanide, they are also called as ethane nitrile, which is react with sodium in ethanol. So, this is the reduction method and this CN molecule they are convert into CH2 NH2 molecule. So, this MCQ based on the Mendius reduction. So, first MCQ, which of the following is the product of Mendius reduction? Option A secondary amine, option B primary amine, option C tertiary amine and option D amide. So, we have already studied in Mendius reduction. This Mendius reduction is useful for only preparation of primary amine. So, the reduction of amide. So, in this reduction of amide, when this primary amine having same number of carbon atoms can be obtained by the reduction of amide by using lithium aluminum hydride in ether. So, this is the reducing agent or sodium in ethyl alcohol. These two reagents, they are used to the reduction of amide molecule. So, for example, suppose this CH3C double bond O NH2, name of this compound acetamide. So, this is the example of amide, and this amide which is react with lithium aluminum hydride in ether or sodium in ethyl alcohol. So, these two molecules they react together. So, this LiAlH4 or sodium in C2H5OH, they produce this 4 nascent hydrogen atom, and this nascent hydrogen atom is responsible for this reduction of carbonyl group. So, in this reaction, this carbonyl group they are converted into, so this C double bond O, this is the carbonyl group, and this carbonyl group they are reduced to CH2 group, so methylene group, and the formation of ethyl amine. So, in this reaction, when amide or acetamide which is convert into only primary amine. So, this is the preparation method of amine from amide. So, the MCQ based on the reduction of amide molecule, and this MCQ is which reagent is commonly used to reduce amide to amines. So, these are the 4 options. Number 1, sodium borohydride means NaBH4. Second, lithium aluminum hydride means LiAlH4 in ether. Number C, hydrogen gas with catalyst, and option D, lithium aluminum hydride in water. So, out of these 4 reagent, so out of these 4 options, the correct option, because in reduction of amide by using this lithium aluminum hydride or by using sodium metal in ethanol. So, these two reagents are used to reduction of amide, hence the correct option is lithium aluminum hydride in ether. The next MCQ, important method, Gabriel phthalimide synthesis method. So, this Gabriel phthalimide synthesis method is used for the synthesis of primary amines, and it involves the following steps. So, this Gabriel phthalimide synthesis they involve 3 steps. Number 1, formation of potassium salt of phthalimide from phthalimide on reaction with alcoholic potassium hydroxide. So, alcoholic potassium hydroxide which is react with phthalimide, they convert the potassium salt of phthalimide. So, this is the first step. Second step, the formation of N-alkyl phthalimide from potassium salt by reaction with alkyl halide. And number 3, alkaline hydrolysis of N-alkyl phthalimide to from alkaline, third step, alkaline hydrolysis of N-alkyl phthalimide to form the corresponding primary amines. So, these are the 3 steps involved in the Gabriel phthalimide synthesis. So, we see the actual reaction of this Gabriel phthalimide synthesis. So, step 1. So, this is the structure of phthalimide. So, this benzene ring which is attached to C double bond O NH C double bond O. So, this molecule they are called phthalimide, and this phthalimide which is react with alcoholic solution of KOH by removing the water molecule. So, this hydrogen atom of phthalimide is replaced by potassium atom or potassium ion, and to form this N minus K plus, and they are called potassium salt of phthalimide. So, in first step formation of potassium salt. In second step, this the formation of in first step molecule potassium salt of phthalimide, which is react with alkyl halide Rx. And so, in this reaction, this potassium ion is replaced by alkyl group and to form N-alkyl phthalimide. So, in step 2, the formation of N-alkyl phthalimide. And in third step, the N-alkyl phthalimide, which is on alkaline hydrolysis, means addition of NaOH molecule. So, breaking of these two bonds. So, this RN group, and actually they using twice NaOH, two molecules of NaOH. So, this two hydrogen atom which is attached to this nitrogen atom and to form RNH2 molecule, to form RNH2, and this twice ONA group which is attached to this 2 carbonyl group and to form this benzene C double bond OONA, C double bond OONA. This oxygen atom having partial negative, the oxygen atom having negative charge and sodium atom having positive charge, and this is the sodium phthalate. So, it is a sodium salt of phthalic acid, and the actual product is primary amine. So, this Gabriel phthalimide synthesis is only for the preparation of primary amine. This which type of amine can be prepared using Gabriel phthalimide synthesis? 4 options. Option A primary amine, option B secondary amine, option C tertiary amine, and option D aromatic amine. And we are already studied in Gabriel phthalimide synthesis. This method is useful for the preparation of only primary amines. Which of the following amines cannot be prepared by Gabriel phthalimide synthesis? So, these are the 4 options. Option A ethylamine. So, ethylamine, it is the example of aliphatic amine. N-propylamine or propylamine, this is also aliphatic amines. Number C aniline, and number D butyl amine. So, out of these 4 options, we have already studied in Gabriel phthalimide synthesis aromatic primary amines cannot be prepared by this Gabriel phthalimide synthesis. So, the correct option is aniline, because aromatic amine cannot be prepared by Gabriel phthalimide synthesis. So, aniline cannot be undergoes nucleophilic substitution reaction. Third, by Hofmann's degradation. Hofmann's degradation is also called as Hofmann's rearrangement, Hofmann's bromide degradation, Hofmann's hypobromite degradation. So, in this reaction, when amide on warm with bromine and concentrate aqueous solution of KOH or NaOH. So, in this reaction, suppose RC double bond ONH2 molecule which is react with Br2 and 4 molecules of KOH or NaOH, and this is the aqueous solution of KOH or NaOH on heating. So, in this reaction, the removal of this carbonyl group and to form RNH2. So, this NH2 group attached to alkyl group and removal of this carbonyl group and to form RNH2 means primary amine plus twice KBr plus potassium carbonate and water molecule. So, this is also the preparation of this method is also preparation of primary amine from amide, but this reaction they having one carbon atom less than corresponding amide molecule. So, hence they are called degradation. Degradation means one carbon atom less than corresponding reactant molecule. So, for example, CH3C double bond ONH2, name of this compound acetamide, which react with bromine and 4 moles of KOH in aqueous and heating. So, this carbonyl group of acetamide remove and this NH2 group attaches to CH3 carbon atom and to form methyl amine plus twice KBr plus K2CO3 and twice water molecules. So, this is the example of Hofmann's degradation reaction. So, next we have discussed some MCQ based on Hofmann's degradation reaction. The number 1, how many moles of KOH are required per mole of amide in the Hofmann's bromamide degradation? So, out of these 4 options, we have already studied the 4 moles of KOH or NaOH is required to convert the amide molecule into amine molecule. So, the correct option is option D, means 4 moles of KOH required. Second MCQ, in the Hofmann's bromamide degradation, the carbonyl group means C double bond O of amide is replaced by. So, which group or which molecule they replace this carbonyl group? Option A, an alkyl group, option B, an amino group, option C, a hydroxyl group, and option D, a halogen atom. So, we have studied in this reaction this RC double bond O means NH2 group attached to carbonyl group, they are convert this RNH2. So, in this reaction this carbonyl group of amide is replaced by NH2 group, means amino group. So, the correct option, option B, an amino group. So, the next point, physical properties of amines. The number 1, intermolecular forces. So, we know the structure of primary amine, secondary amine and tertiary amine. This nitrogen hydrogen bond in amine is polar because of the electronegativity difference between nitrogen and hydrogen atom. So, the electronegativity of nitrogen is 3 and electronegativity of hydrogen is 2.1. Hence, they are polar bond, and due to this polar nature of this NH bond or nitrogen hydrogen bond, the primary and secondary amine have the intermolecular hydrogen bonding, and the intermolecular force of attraction is greater in primary amine than secondary and tertiary amine. So, this second state, the lower aliphatic amines are gases with fishy odor, middle members are liquid in form and higher members are solid under ordinary temperature and pressures. Aniline means aromatic amine and other aryl amines are usually colorless liquids, but get colored as they are easily oxidized by air. Means they expose in air, aniline or other aryl amines, they expose in air, they get oxidized and they form colored. So, this is the second physical state or physical property of amines. Third physical property, solubility. Due to their ability to form hydrogen bond, we have already studied in first physical property to formation of intermolecular hydrogen bonding. So, the ability of hydrogen bond with water molecule, lower aliphatic amines are soluble in water. This amine molecule, they bond with hydrogen bonding, they create with water molecule, and due to this hydrogen bonding with water molecule, they form, or the lower aliphatic amines are soluble in water. The solubility of amine decreases in increase in molar mass. So, increase the number of carbon atom. So, they decrease the solubility due to increase in increase in size of hydrophobic part of alkyl group. So, the number of alkyl group increases, decrease the solubility. Then aromatic amines and higher aliphatic amines are insoluble water, because higher members they cannot form bond with water molecule, hence they are less soluble, and aromatic amines they are also do not form the hydrogen bonding with water molecule. So, these are the insoluble in water. So, the water solubility of alcohol, amine and alkane. So, these are the comparison between 3 molecules. The molar mass in water are in the decreasing order. So, highest solubility in water molecule is alcohol, then second priority or second number amine, and third alkanes. So, alkane they do not form intermolecular hydrogen bonding with water molecule. So, they cannot dissolve or they cannot soluble in water. So, some MCQs based on these physical properties. Why are lower aliphatic amines are soluble in water? Option A, they are ionic compound. Option B, they can form hydrogen bond with water molecule. Option C, they are non-polar, and option D, they have higher molecular weights. So, the correct option we have discussed already in physical properties, they can form hydrogen bond with water molecule. Next MCQ, which of the following amine is most soluble in water? These are the structures of amine, or these are the 4 options of amines, and which amine is more soluble? Option A, CH3NH2 means primary amine. B, C6H5NH2 means aromatic amine. CH3 thrice N means tertiary amine, and CH2 twice means secondary amine. So, out of these 4 options, we have studied the lower members or primary alkyl amine is more soluble in water than secondary and then tertiary, and aromatic amine cannot dissolve in or cannot soluble in water because they do not form intermolecular hydrogen bonding. So, the correct option, option A, CH3NH2 means methyl amine. So, due to the hydrogen bond with water molecule, lower amine is most soluble in water. Next physical property, boiling point. The order of boiling point of alkane, amine, alcohols and carboxylic acids are comparable molar mass is as follows. The highest boiling point is carboxylic acid, then alcohol, then amine and alkanes. So, alkanes molecule they are having lower boiling point than amine. So, look at this chart, some examples of carboxylic acid, some examples of alcohol, some examples of amine and some examples of alkane molecule. So, these are the structures, their molar mass and their boiling point. Boiling point is carboxylic acid because they form the strongest bonding between 2 molecules and they are having 414 degrees Celsius its boiling point, and the lowest boiling point is C2H5CH CH3 twice, atomic mass 72 and its boiling point 300.8 degrees Celsius. So, this is the example of alkane. So, alkane is lowest boiling point and carboxylic acid they are having highest boiling point due to the molar mass and intermolecular hydrogen bonding. So, first MCQ based on this boiling point. Which type of amine generally has the lowest boiling point? So, option A, primary amine, secondary amine, tertiary amine and none of the above. Option C, tertiary amine, because of they do not form intermolecular hydrogen bonding in tertiary amine. Why? Why they do not form intermolecular hydrogen bonding? Because the absence of hydrogen atom on nitrogen, so they cannot form hydrogen bonding with another molecule, hence the tertiary amine is the lowest boiling point than secondary and primary amine. Which of the following factors influence the boiling point of amines? Option A, molar mass, intermolecular forces, type of amines, primary, secondary and tertiary, and option D, all of the above. So, these first three options, the which factor affect on the boiling point? The number 1, molar mass increases, boiling point also increases. Number 2, intermolecular forces. So, intermolecular force or intermolecular hydrogen bonding increase the boiling point. So, this factor also affect on the boiling point. Number 3, types of amine, primary, second and tertiary amine. In primary amine, they are having highest intermolecular force of attraction between another molecule. Then secondary and tertiary, they do not form intermolecular hydrogen bonding. So all three are factors, they influence on the boiling point. So the correct option D, all of the above.